All right, by popular demand, this is the Stats Chapter 6 and 7 practice test. The first thing it says is standard normal distribution. Standard normal distribution means that the middle is 0 and the first standard deviation is 1. So 0 is the middle, that's your mu, and your standard deviation is 1. So it says if a person has a z-score, so this standard deviation of 1 means the z-score is equal to 1. So the z-score matches the actual standard deviation. So here's the picture. If a person scores a z-score of 0.3, what's their percentile ranking? So there's 0, so here's 0.3. So 0.3 would be this probability there plus the 50% that's down here. So it's this part and then all of that part. So we know that's 50% and another part there, 10, 12, 15%, whatever. So what we're going to do is we're going to go to the distribution on the calculator here. So second distribution, normal distribution, we want to go all the way to the left. So that's negative second EE 99. And we're going to 0.3. And again, this is the standard normal curve. So 0 is the middle, that's the average, and the standard deviation is 1. That's the most basic bell-shaped curve there is, 0 and 1. Then from there, we do all the adjusting. 61%, so this is 61.79. I'm going to round that up. I got the decimal, I wrote it down as a percentage. So the percentile ranking is 62%, 62 percentile. Okay, find the probability a person scores between 1/2 and 1.2. So again, 0 is the middle, 1/2 negative is here, so we want that probability, and then 1.2 here. All right, so again, we just go second distribution. We're going to go from negative 0.5 to 1.2. 0 and 1. Again, this is the standard normal curve. So a certain medical procedure follows the standard normal curve. Boom. So 57% chance of doing that. So the probability that negative 0.5 less than x, which is less than 1.2, the chances between that is 57%. So it's negative or 0.5764. Okay. These can be looked up on the table. Remember I gave you a table? So 4515, you can look up on the table here, 4515, 4515 is a little bit more, 1.66. So it's right there, 4515 is 1.66. But if you didn't want to look it up on the table, this is where you do inverse norm. And again, this is for a standard normal curve. See, it says standard normal curve. So that's this curve right here. So we're basically just doing inverse norm on these. You're given the area. Now, if you're going to use the calculator goes all the way down. Okay, so we're going to go ahead and put that on there. So the area is going to be 9515.9515, because I'm going to add that 50% on. Plus that would be the 9515. 0 and 1, and I want it to the left. So the table rounds. I got 166, so 165, yeah, 16595. Okay, this z-score is negative because it's over here. All right. So what we're going to do here is we could figure out that part right there, and then from there over, we could do left, and then we know what that is. So let's see, 0.5 minus 0.3980, that, okay, enter. So we know that 10% is over here, 0.102. So I'm going to go second inverse norm, and I just want 10%, 0.102 to the left. and it tells me that it is negative. Negative 1.27. Yeah, that's close enough. 3980. So if you look up 3980 here, 3980 is right there, 1.27, right? 1.27, but it's to that side, so it's negative. Okay, so this is 71%. If your calculator only does left, you could do it to the left, but then make it be a negative z-score. But my calculator will do right. So we'll do second distribution, inverse norm. The area I want is 0.7190, 0.1, and I want it to the right this time. Paste. So 57.99, negative 0.5799. Okay, so there's that page. Okay, so we got Mr. Smith's farm here, and it says the ripe watermelons on the farm are distributed normally with a standard deviation, so my sigma is equal to 2.8 and a mean mu of 20.26. Find the probability that a random selected watermelon, so this is just one watermelon, this is not chapter 7 yet, we're just pulling one watermelon out of the patch. So a probability that X is less than 19 pounds. All right, so we're not adding up all the sums or finding the average of 20 watermelons. So there's no N in this. It's just pulling out one watermelon. So we go second distribution, number 2. We want to go to the left because we want less than, so that's correct. My upper is 19. My average is 20.26. My standard deviation is 2.8. I don't have to divide by the square root of n or anything like that because it's just one watermelon I'm pulling out. 32%, 3264. Okay, so we want to do probability that the watermelons are less than X and less than 22, so between those two. So we go second distribution, inverse norm. Lower is 21, upper is 22. Yes, yes. Paste. 12%. 0.1286. So that's 12.86%. Okay, upper 15%. So I want to know the cutoff for upper 15%. So I want 15% of the area right there. Okay, so the middle is 20.26, right? I want to know what is that value there? What's the cutoff for the upper 15%? So this is where we do inverse norm, and I want 15%, or 85% to the left. So we could do it that way too. 0.85, 20.26, and 2.8 to the left. And boom, boom. 23.162. 23.162 pounds is the cutoff. All right. 01, the mean reading score was a 21.3, a standard deviation of 6. The scores are normally distributed. Okay, so what's the probability that a sample mean of 25? So now we have n is equal to 25. So this is chapter 7, where I have to like adjust. 25. What's the probability that the sample mean of 25 students is more than 22? Is 21.3, and I want to know that it's more than 22. So it's going to be above the 22. All right, so we want probability that X bar is greater than 22. All right. So we got more than 22, more than 22, more than 22. So we got second distribution, normal distribution, more than 22, so my lower is 22. My upper is going forever, so the positive infinity, so EE, whoops, second EE 99. My average ACT score for reading is 21.3. Standard deviation is 6 divided by 25 students, the square root of 25, or you could just divide by 5. 27%, 0.27, 2798. Okay, cutoff score for the 35%. So 21.3 is the middle. We want 35% of the area right here. So this is an inverse normie. So what X bar would do that? What average would be in the 35th percentile? So we know the area is 35. So inverse norm, 35%. The average is 21.3. My standard deviation is 6, but I'm going to divide it by the square root of 36 this time. Or I could just divide by 6. Well, that's easy. 6 divided by 6 is 1. And I want it to the left, so I chose left. Oh, I hit a wrong button here. Second inverse norm. I want 35%, not 85%. $20.91. So I did the wrong percentage, it's 35%. Man, I need water bad. Water is so good. Okay. Now, this problem here, given a distribution in this distribution here, Px, so this is an individual. So what's an individual is greater than 20. All right. So I go to second distribution. I know it's an individual score. That means an average score because it's X bar. X bar is the average. So just finding an individual that has 22. So inverse norm, I'm going greater. So my lower is 22. My upper is 1. Second EE 22. No. To infinity 99. My average is 20. My standard deviation is 5. Paste. Enter. 34%. 3446. So 34.46%. Now I'm doing less than 21. So the middle is 20, but I want to have all the average of 100 things be less than 21. So second norm 21, and I'm going, no, that's no, I'm going down below. So the lower is 1 second EE 99. Second EE 99, 21. Lost my train of thought. 21. Okay, my average. Oh, it's 20. Okay. 20, and the standard deviation is 5, but I need to divide it by the square root of 100, and I multiply by the square root of 100. Man, I'm getting tired. Second insert divided by, there we go. 97%. So it's 0.9972. Ba-boom. Okay, so 18 to 21. 18 to 21 is second distribution. 18 on the lower, 21 on the upper, 20 and 5. This is just an individual score. 23%. 0.2347. Okay, now we're going to find where 2.5% is. So this is an inverse norm question. It's also on the average because it's X bar. So I hit second distribution, inverse norm. I want 2.5%, 0.025. My average is 20 because it's 20. My standard deviation is 5. But since it's out of 64, I have to divide by the square root of 64, which is 8. And I want, yeah, less than, so it's to the left. 18.77. So X bar has to be 18.775. All right. So Mr. Ryan Colton and his wife cannot have children, and they decide to adopt a kindergartner because it is more likely to be potty trained. During the adoption process, they learn that the kindergarten weights are normally distributed with a mean of 39 inches and a standard deviation of 2. Ryan says to his wife, "I want a big one." What is the probability that Mr. Colton gets one greater than 44 inches? So this is just probability that X is greater than 44 inches. All right, this is going to be not a very good chance of doing this. So I go second distribution, normal. We want to be above it, so 44 is the lower, the upper is 1, second, EE 99. Kindergarten is 39 with a standard deviation of 2 inches. Paste. 006, 0.006. 2. So not very big, less than 1%. Ryan Colton then wants his kid to stand out in a kindergarten class. What is the probability he finds a class of 20 students? So this is where N is equal to 20 with an average height of only 34 inches. So probability that X bar is less than 34 equals. So second distribution, boom. -1 second EE 99 because we're going down, so it would be less than. Then the upper is 34. 39 is the middle, 2, but it's the standard deviation is 2, but it's out of 20 students. So second square root. Oh, we got to divide. Divided by second square root of 20 students. Zero. So basically there's no chance of finding that. Okay. Uniform distribution. So we're rolling a die, right? We're going to add the sums up. So what are you going to roll? You're going to roll 1, a 2, a 3, a 4, a 5, or a 6 on a die. We start adding them up. Well, the middle is 3.5. So mu is equal to 3.5. That's the average. The standard deviation for a uniform distribution is b minus a squared divided by 12 by 12, then take the square root. So b minus a would be 6 minus 1 because it's the upper number of 6, lower number of 1 squared over 12, take the square root. So that's 5 squared, 25. So it's going to be 25 twelfths, take the square root. So it's 25 divided by 12, take the square root, enter to the power of 0.5. That's how you take the square root. 1.4434. So standard deviation is 1.4434. All right, that's how you get the standard deviation for a uniform curve. It's this formula right here. Okay, what's the probability that the sum of all the dice will be more than 375? So what's the expected value here? 100 dice, 3.5 times 100, well, your expected sum would be 350, right? Because you're going to roll 3.5 100 times. So that's what you would expect. So we want to go to 375. So we want probability that our sum is greater than 375. When I did the problem originally and did 400, it didn't work out very well, so I changed it to 375. All right. So we go second distribution and normal, and we want to go above this time, so 375 is my lower, 1 second EE 99, and my average is 350. That's what I would expect. My standard deviation is 1.4434 times second square root 100. Okay? Because you have to, when you do the sum, you multiply with the square root of n, not divide by it like in the other ones. Paste. 0416. All right. Was the probability that the mean of 100 rolls is less than 3.2? So now we want the probability that the average is less than 3.2. So the average expected value is 3.5. So what's it less than 3.2? Okay, so we're going to do second distribution, number 2. We'll be less than, so it's -1 second EE 99 and 3.2. My expected value is 3.5, and my standard deviation is that, and then we're going to divide by, so I'll change that to divided by the square root of 100. Paste. 0.188. Sayonara, baby.